and good morning to all. I am Professor Devendra Singh, taking this course on machine design, and this is our sixth lecture in this module. So, the content of this lecture are are primarily the various types of loads we will discuss and various modes of failure we will discuss in this lecture. Earlier we have discussed the simple stress strain for mild steel and other materials comparison in the last lecture, and material properties we have discussed in the last lecture. Now, we will focus this lecture on the various types of the loads, though we have discussed little bit various types of load in the last lecture. So, first we start with the various types of load. So, mechanical load, I am talking about the mechanical load here. So, mechanical load as far as concerned, we can classify in two groups broadly. मैकेनिकल लोड को दो ग्रुप में हम डिवाइड करते हैं प्राइमरली. पहला है स्टैटिक लोड and second one is the dynamic load. Static load is the load the magnitude or the direction will remain constant or will remain same with respect to time, and dynamic load are the loads either the magnitude or the direction or both changes with respect to time. So, that we have discussed in the last lecture. Further, the effect of these loads on the basis of the effect, we can further classify as the tensile load. If there is a tensile effect on the member, then this is considered as a tensile load, static or dynamic. Then compressive, if contraction is there due to the application of the load, then this is a compressive load. अगर member को ये दबाता है तो compressive load है. Then tangential load, if the load is applied in the tangential direction and it creates some shearing effect, then this is tangential load. The effect of tangential load is the primarily the shearing. Then bending load, if we apply the load and effect is the bending, then this is called the bending load. Then the torsional load, if torque induce all the or we apply the load which can cause the torsion in the member, then this is called the torsional load. So, these are the effects. On the basis of effects, these two types of loads can be classified further, and we will understand throughout our syllabus what type of the load and how we should handle these loads during the design. We will learn during our course when we move further. जैसे जैसे आगे बढ़ेंगे इनको कैसे हैंडल करना है, कैसे हमें यूज़ करना है, एनालाइज करना है, वो सब हम सीखेंगे अपने आने वाले लेक्चर्स में. Then the effect is, we start with the simple stress. So, stresses can be primarily the normal stress and the shear stress, tangential or shear stresses. So, normal stress, the stress which is perpendicular to the plane at which it is induced, these are the normal stress, and the tangential shear stresses are those stresses which are induced at the plane in the tangential direction. So, this is shear stress. So, normal stress we can further classify in two groups. दो तरीके की होंगी normal stress, tensile stress, compressive stress, and tangential stress अपने आप में होगी. और हमें ये भी ध्यान देना, आगे हम हालांकि इसको डिस्कस करेंगे कि बैंडिंग स्ट्रेसेस, बैंडिंग लोड की वजह से जो स्ट्रेसेस होंगी ये यूज़ की रहेंगी आपके लिए. बैंडिंग स्ट्रेसेस और बैंडिंग लोड की वजह से जो होंगी वो दो तरीके की होंगी एक ही मेंबर में एक साथ. आई एज्यूम कि इन द लास्ट सेमेस्टर जो आपने स्ट्रेंथ ऑफ मटेरियल पढ़ा है उसमें बैंडिंग पढ़ी है, तो बैंडिंग स्ट्रेसेस यू हैव अवेयर, यू हैव लर्न. सो बैंडिंग स्ट्रेसेस हमेशा नॉर्मल स्ट्रेसेस होती है नेचर में, और जिस तरफ लोड लगता है उस तरफ कंप्रेसिव न्यूट्रल एक्सिस के उस तरफ जिधर से आपने लोड लगाया बैंडिंग लोड, जिधर को बैंड हो रही है, तो उधर कंप्रेसिव स्ट्रेस उस फाइबर में और दूसरी अपोजिट साइड में टेंसाइल स्ट्रेस होती है हमेशा. एंड टॉर्क टॉर्जनल स्ट्रेसेस shear type होती हैं. Torsional stresses are shear type. So, we will when we deal with the shaft design of shaft, we will take these in details and some numerical problems we will take in this unit also. Stresses caused by bending and torsion. So, first the bending stress and torsional shear stress. Bending stresses मैं discuss कर चुका हूँ अभी. These are of tensile or compressive. अगर इसको हमें देखना है तो suppose this is a member, rectangular beam, it is subjected to the bending. It is subjected to the bending. So, अगर इसे bend करेंगे तो bend करके किस तरीके से जाएगा, bend करके ही कुछ इस तरीके का बनेगा, कुछ इस तरीके का बनेगा. ऊपर वाला फाइबर शॉर्ट होने की टेंडेंसी, शॉर्ट होगा लंबाई में, ये इलोंगेट होगा. सो ऊपर कंप्रेसिव, यही इफेक्ट बेंडिंग का, ऊपर कंप्रेसिव, नीचे टेंसाइल स्ट्रेसेस. और जब आप एक नेचर से दूसरी तरफ जा रहे हैं, कंप्रेसिव स्ट्रेस वी कंसीडर एज अ नेगेटिव एंड टेंसाइल एज ए पॉजिटिव व्हेन वी प्लॉट. So, if we are moving from positive to negative or negative to positive, we will definitely get a 0 point, that is called the neutral point. So, when you move from the top to bottom, there is a plane you will get where there is no strain, and as per the Hooke's law, if there is no strain, then stress is 0. Stress is directly proportional to strain. Sigma is equals to E epsilon, that we have learnt. So, if strain is 0 at any fiber, then stress is 0, and that plane is called the neutral plane. And in our diagrams, we normally indicate that as an A. So, this is the neutral plane. This is the neutral plane here. जो हरे रंग से दिखाया है, this is neutral plane, जिसमें कोई ना elongation है ना contraction है. Yes, there is a curvature, and the axis and the line, the centroidal line at this plane, that is denoted by an A, that is called the centroidal axis, and the distances of fibers where we need to find out or where we wish to calculate the stresses always defined with respect to the neutral axis. So, चाहे ऊपर की तरफ जाए चाहे नीचे की तरफ, सो वो जो डिस्टेंसेस होंगी वो फार्मूला आपने फ्लेक्सर फार्मूला की पढ़ाया है स्ट्रेंथ ऑफ मटेरियल में. y is always measured with respect to neutral axis, and this is bending moment I have shown here applied. You can think if this is a beam, simply supported beam, and you have applied W load, the same effect bending you will get in this beam, the same effect. So, it will be depending on the wisdom to understand what is the effect and what type of the stress is induced in it. So, as far as the stress we want to calculate at any plane, this is the cross section. So, on the upper side, these are in red color. So, normal stresses इस डायरेक्शन में I consider positive, इस डायरेक्शन में negative. Negative means this is I show this is compressive stress, this is tensile stress. So, these are in the left hand side direction at this plane, at any plane for the cross section if you want to get. So, this is the graphical representation of the stresses above the neutral plane. So, this is 0, and then continuously it is increasing, and the maximum stress, compressive stress appears on the topmost fiber. And similarly, on the other side, these are in green, these are the tensile stresses, and tensile stress 0 at the neutral plane here, and it is increasing towards the lowermost fiber. So, I think everybody is aware about कि हमारा फ्लेक्सरल फार्मूला क्या है, m by I is equals to sigma b upon y is equals to E upon R. तो यहाँ से हम, दिस इज फ्लेक्सरल फार्मूला, यहाँ से आपको मिलता है सिग्मा बी इज इक्वल्स टू m by I y y. This is I y y is nothing, this is the section modulus and I is the moment of inertia of the cross section of about the neutral axis, moment of inertia of the cross section about neutral axis. So, whatever is the shape of the cross section, we need to calculate the moment of inertia for circular section. Also, here we have this formula. Here we have this formula, sigma b is equals to m y by I. So, we can calculate the bending stress at any fiber which is having a distance of y from the neutral axis, which is having the neutral axis से y distance पे हो, तो ये फार्मूला हम इस्तेमाल करके stresses निकाल सकते हैं. Right. Now, the stress is caused by a torsion. This is circular rod which is supported at another end rigidly, and we apply, the diameter is d of this and this is the axis, and we apply some torque. Then it will having a twisting effect, it will having a twisting effect because other end we have fixed here. This is the rigid support here. If you apply, then twisting effect is there, then it will induce the sharing effect on the adjacent cross section. They are trying to slip with respect to each other. So, this is the cross section, and when we move from the axis, if we are considering this is a plane and this is the center of the plane and other plane is this, and this is trying to move like this. So, the motion, it will rotate about it, this section is like this. So, here the stress is 0 and the resistance to maximum deformation can take place on the upper fibers. So, maximum deformation, maximum slip can take here or here, and here this is 0. So, again we are interested in to have our elements within the elastic limit. So, again the stress is directly proportional to strain. If there is no displacement, no deformation, then the strain is 0. So, according to that concept, at the center or at the axis, the stress will be equal to 0. The stress distribution, if we want to plot, then this is the central axis, and at this plane, if we want to, this Taumax, because the maximum strain at the upper and lower fiber, then the Taumax we will have, because during as I have applied this torque in this direction. So, the resistance definitely to keep this element in shape, तो रेजिस्टेंस जस्ट उसके अपोजिट होगा, तभी ये एक दूसरे को बैलेंस कर पाएंगे. दैट्स वाई अगर हम इसे देखें तो ये वाला, ये डायरेक्शन जो हमने यहाँ पे दिखाया है, दिस इज टॉमैक्स फॉर द अपर. सिमिलरली इस टॉर्क के लिए अगर मैं इसे अलाउ करूँ डिफॉर्मेशन, देन इट विल मूव इन दिस डायरेक्शन, एंड अगर इस एलिमेंट को मुझे इसी शेप में रखना है, सो मुझे रेजिस्टेंस ऑफर करना पड़ेगा इसका अपोजिट. सो दिस इज द डायरेक्शन, दिस इज टॉमैक्स. देन टॉर्जन फार्मूला स्ट्रेंथ ऑफ मटेरियल में आप पढ़ चुके हैं, अगर उसे आप देखेंगे तो दिस विल डिफॉर्म और दिस विल deform uniformly linearly we assume, and the stress distribution will be like this. This is the maximum, then it will come to the lesser one, then it will here this is 0, and then this is the stress distribution due to the torque, and this is the formula for the shear stress due to the torque is T r upon j, and j upon r is nothing, this is polar section modulus. This is polar section modulus. So, the effect of eccentric loads. The third type of load we come across in machine design, that is eccentric load. So, eccentric load is always having at least two simultaneous effects. So, what are the eccentric load? First of all, the eccentric load, if the line of action is having some offset distance from the central axis, then this is called the eccentric load, and the same circular rod I am considering here to discuss this effect of eccentricity or eccentric load. So, if we apply, this is the cross section area A and this diameter, then this F is applied. This is the central axis, and here this is the distance E, this is the eccentricity. So, this is eccentric load, it will have two effects simultaneously. So, what is that? This is, I have removed the support and I will consider the reactions on the CD, on BC and AD. So, this is the axis F as it is. So, if F is here, so to balance at other end, F should be acted at A, and similarly E is the effective point where we have applied the load at the eccentricity. Now, at this axis we will use two dummy forces for the analysis purpose. One, F I have applied here, F applied here. So, if I use this, अगर मैं ऐसा करता हूँ तो जो सिचुएशन मुझे दी थी मैंने वो चेंज कर दी. Now, I have to neutralize the effect of what we have applied. अगर इसको मैंने इसी के अपोजिट फोर्स इधर को इतना ही लगा दूं, इतना ही इधर को लगा दूं, तो यहाँ पे जो रिजल्टेंट फोर्स हो जाएगा एक्सिस के अलोंग वो हो जाएगा 0. तो हमारी ये जो यहाँ पे हमने इसे कन्वर्ट किया है, इस डायग्राम को अलग इस सिचुएशन में लेके आए हैं. सो इट विल हैव द सेम सिचुएशन एज इट इज गिवन इन द आवर पिक्चर. सो दिस इज, सो एनालिसिस कभी भी इसेंट्रिक लोड की करनी हो, सो इसेंट्रिक लोड के बराबर इक्वल एंड अपोजिट सेंट्रल एक्सिस के अलोंग इक्वल एंड अपोजिट फोर्सेस लगा दीजिए. सो और देखिए फिर क्या क्या इनके पेयर बनते हैं. तो अगर मैं यहाँ पे बात करूँ तो ये वाला और ये वाला इक्वल एंड अपोजिट पैरेलल फोर्सेस हैं, तो ये कपल फॉर्म करेंगे और ये वाला फोर्स इसमें टेंशन देगा. उसी तरीके से ये और ये मिला के इधर से कपल, दोनों के डायरेक्शन अपोजिट. सो इट विल क्रिएट द बैंडिंग इफेक्ट एंड दिस इज एफ टेंसाइल, एफ टेंसाइल. सो दो तरीके के इफेक्ट्स यहाँ पे साथ के साथ दिखाई देंगे. वो इफेक्ट्स यहाँ पे आप इसे देखें. सो पहले एफ टेंसाइल, इसके साथ में दूसरा इफेक्ट क्या है, ये एफ केवल मैंने ये कंसीडर किया, ये कंसीडर किया, इन दोनों का इफेक्ट इस पिक्चर में है. अगला इस डायग्राम में है. अगला इफेक्ट इस पे अगर मैं बात करूं, इस पे फोर्स लगाया मैंने. अब इसको फोर्स लगाया तो इधर एफ एंड एफ कपल, एफ इंटू ई कपल फॉर्म किया. इस कपल की डायरेक्शन क्या होगी, ये डायरेक्शन होगी, ये सबको मालूम है. एंड दूसरा फोर्स, ये दूसरा मैंने लगाया तो इसकी कपल की डायरेक्शन क्या होगी, ये होगी. सो इसेंट्रिक लोड, अब इसके इक्वलेंट ये दो इफेक्ट हैं, अगर ये दो एक साथ लगाए जाएं तो वो वही इफेक्ट करेंगे जो हमने इसेंट्रिक लोड एफ लगाया है. सो दिस इज द वे how we can analyze the eccentric load. This is, so how it is. This is equal to nothing, this is banding, m is the banding moment, that is F into E, magnitude is F into E. And now, if you write the expressions, so primary primary stress and the secondary stress, or primary stress is also termed as the direct stress. So, that is the stresses which are having the basic dimension of fulfill, or we calculate force upon area by that basic formula we are getting, that is primary direct stresses. So, primary is the tensile stress, that is F upon A is equals to plus 4 F upon pi d square, plus means this is tensile, and then we have secondary stress, that is bending stress. So, bending stress is sigma S is equals to plus minus m upon z, plus minus because in one fiber means in CD it is tensile in nature, and in AB it is compressive in nature. So, bending moment is F into E. So, we that is equals to I upon Y, that is pi d cube upon 32, that for particularly for circular cross section. So, we use I upon Y, any cross section we can deal, and resultant stress, this is our primary stress, this is our secondary stress, we have already discussed, दोनों को ऐड करेंगे. So, we will have this final effect of final stress distribution here. So, this is the maximum stress in this particular case. As far as the resultant stress is concerned, they are in the same direction. So, we can get the algebraic sum sigma p plus sigma s. Stresses are tensor quantities, we should always remember. So, they are having the same line of action, that is why we can get the resultant by adding up algebraically. Sigma r is equals to f upon a plus minus m upon z, and if we write it, sigma r is equals to 4 f upon pi d square, 4 f upon pi d square, for this a is pi d square by 4, m by z 32 m upon pi d cube. So, we can further do it like this. So, if some force P is applied along with the eccentricity, this is the next situation, applying the same. So, इसका और इसका इफेक्ट अगर बात करें तो ये इफेक्ट है, that we have discussed in the last slide, और ये हमारा अप्लाइड फोर्स P है, ये टेंसाइल है. सो ये हमारे दो प्राइमरी कंसिडरेशन में रहेंगे, दो फोर्सेस P का और F का इफेक्ट टेंसाइल रहेगा. सो वी विल यूज P अपॉन A प्लस F अपॉन A. A इज द क्रॉस सेक्शन एरिया, and this will be analyzed as we have discussed in the last slide. F upon E, F multiplied by E, that is a bending moment, it is a bending effect. So, ऊपर वाले फाइबर पे इधर कंप्रेसिव रहेगा और इधर टेंसाइल रहेगा. So, we can get the net effect here, this sigma d P upon A इसके लिए, here sigma P F upon A इसके लिए, और सेकेंडरी m अपॉन z इसके लिए. अगर हम इसे तीनों को देखें, सो फिर ये हमारे एक लाइन में मिलेंगे, लीनियर, इनका लाइन ऑफ एक्शन कोलिनियर रहेंगे इन इस तीनों स्ट्रेसेस के. दैट्स व्हाई वी कैन गेट द रिजल्टेंट स्ट्रेस बाय एडिंग ऑल दीज थ्री. तीनों को निकाल के वी कैन गेट द व्हाट इज द रिजल्टेंट फोर्स, और सॉरी रिजल्टेंट स्ट्रेस. नाउ द प्रिंसिपल स्ट्रेसेस आर दो स्ट्रेसेस, normal stresses at the planes where the shear stresses are 0. This is the case I have discussed, I have presented here for the biaxial state of stress. It is having sigma x sigma y as a normal stress, and tau x y is the shear stress. Then the principal stresses, the formula is given, sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau x y square. Similarly, tau x is equals to this section, this is always the tau x, and another you should always remember, strength of material में पढ़ा है, sigma max minus sigma minimum divided by 2, principal stress is maximum or principal stress is minimum, difference divided by 2 will give you the maximum shear stress. Now, what is the meaning of it? So, this is the only I am presenting here the Moser for this state of stress what I have shown here, जो यहाँ पे state of stress है उसके लिए Mohs circle मैं यहाँ पे draw कर रहा हूँ और इसको हम अगर draw करें, this is the Mohs circle, सबको मालूम है कैसे Mohs circle होता है. So, what is the maximum stress is this and what is this is the diameter, diameter का आधा radius होगा, उसे आप करेंगे एक्सरसाइज में एंड दिस इज tau max. इफ यू रेफर दिस यू विल गेट tau max is this, tau max is this is the radius, you can get what is it. So, in the modes of failure, types of failure, engineering failure, physical failure and the possible mode of failure under static load, elastic deflection, general yielding and physical fracture I will take in the next lecture. For today, this is from my side. So, thank you very much.